You know, whenever you look up at the night sky, you have to wonder, just how far away is all of that really? It's probably one of the biggest questions in astronomy and honestly, one of the hardest to answer. The universe is just unimaginably vast, and to measure it, you need some seriously clever tools. Well, today we're going to dive into a brand new technique, a real breakthrough pioneered by Indian scientists that's literally set to redraw our map of the cosmos.
And our whole story really starts with incredible objects like this one you're seeing, the Vela Pulsar. Now these aren't just pretty pictures for our telescopes, they're more like cosmic lighthouses. For decades, astronomers have used them to try and navigate the vast, dark oceans of space. The problem is, sometimes the light from these beacons can be a little deceiving.
Alright, so to really get what's so special about this new discovery, we first need to understand the main tool we're working with here, these amazing things called pulsars.
So, what in the world is a pulsar? Okay, imagine a star, way, way bigger than our sun, that's reached the end of its life. It collapses in on itself, forming this incredibly dense little core that's spinning hundreds of times a second. As it spins, it blasts out these powerful beams of radio waves. And if one of those beams happens to sweep past us here on Earth, our telescopes pick up a pulse. The really crucial part, the timing of these pulses is unbelievably regular. It's like finding the most perfect clock in the entire universe.
Now, having a clock that precise has let astronomers use pulsars to guess at cosmic distances for a long time. But there's always been a catch, a pretty big flaw actually, that makes the old method more of a rough guess than a precise measurement.
So the traditional way of doing this is called dispersion measure, or DM for short. The idea behind it is actually pretty straightforward. As the signal from the pulsar travels across space, it's got to push through this thin soup of charged particles, plasma. This stuff slows the signal down. But, and here's the key, it slows down lower frequency waves a little more than the higher frequency ones. So by measuring that tiny little delay, astronomers could estimate how much stuff the signal went through, and from that work backwards to figure out the distance.
But, and it's a big but, here's the problem. That whole dispersion measure method, it has to assume that the fog of particles between us and the pulsar is perfectly even. And in reality, space is anything but even. It's clumpy. When you're looking at really complex, dense areas, like the massive Gum Nebula, that assumption just completely falls apart. And your distance estimates, they become super unreliable. It's like trying to measure how far away a streetlight is in a really patchy fog. Okay, so if our main method has this huge blind spot in these really interesting, complex parts of space, what do? How do we see through that fog and get a real measurement? Well, the answer, it turns out, comes from a brilliant new technique developed by a team of Indian astronomers. They figured out a way to not just see through the fog, but to actually use the properties of that fog to their advantage. It's giving us a much clearer picture of the cosmos.
Their big idea has to do with this other effect, something called scatter broadening. You know how stars seem to twinkle in the night sky? That's our atmosphere bending their light. Well, the same kind of thing happens in space. That clumpy plasma scatters the pulsar's radio signal. So instead of a sharp, clean pulse, you get one that's kind of smeared out. The genius part is, how much that pulse gets smeared out is directly connected to how much turbulent plasma it passed through. And that gives us a second, totally separate clue about the distance.
And you know, we really have to give credit where it's due. This incredible work is the result of a fantastic team effort from some of India's best scientific institutions. We're talking about folks from IIT Kanpur, the National Center for Radio Astrophysics, and the Raman Research Institute. This is a really big moment for Indian astronomy on the global stage.
So, the real magic of this new method isn't just about noticing the scattering effect. It's about combining two separate clues, the old dispersion measurement and this new scattering measurement, to solve the puzzle of cosmic distance way more accurately than ever before.
I love how the study's lead author, Ashish Kumar, put it. He said, previously we had only one soldier, dispersion, to solve the problem. Now we have two, dispersion and scattering. I mean, that just says it all, doesn't it? It perfectly explains why their approach is so powerful. Two independent clues are always going to be better than one. And to make sure their method actually worked, the team was incredibly systematic. They picked 10 pulsars located inside that messy, hard-to-measure Gum Nebula. For each one, they measured both the dispersion and the scattering. Then they built a computer model of the nebula and basically tweaked it step by step until the predictions from their model perfectly lined up with what they were actually seeing with their telescopes. And that exact point, where the model and reality clicked, that revealed the pulsar's true distance.
And boom, they got real, concrete results. For example, their work finally confirmed something astronomers had suspected for a while, that the famous Vela pulsar is actually located behind the front shell of the nebula. That's a huge piece of the puzzle for understanding the real 3D shape of our galaxy.
So what's the big picture here? What does this all mean for the future? Well, this isn't just a small fix. This new technique fundamentally changes our ability to map the universe. It's really opening up a whole new cosmic horizon.
Right now, the gold standard for measuring cosmic distances is a method called parallax. It's incredibly accurate, but it has a hard limit. It just plain can't measure things that are too far away. This new Indian method, though, it doesn't have a specific distance limit, and that is an absolute game changer.
I mean, just think about the possibilities here. They're astounding. Astronomers can now seriously start thinking about measuring distances to things outside of our own Milky Way galaxy. This could be the breakthrough we need to finally figure out the distance to those mysterious fast radio bursts, and the team is already planning their next move, a bigger study of 300 more pulsars to build a truly three-dimensional map of our entire cosmic neighborhood.
So what this breakthrough really gives us is an incredibly powerful new tool. It's not just a new ruler, it's a whole new way of seeing the universe in its true three-dimensional glory. And it just leaves you with this one exciting thought. With a yardstick that has no limit, what incredible cosmic secrets are we about to unlock?